All right, guys, so today we are going to move on to 4.7, which is linear and non-linear functions. And like always, I'm going to go ahead and highlight my title to keep things organized. We're going to go ahead and start by looking at linear functions. And then we'll go ahead and switch gears and talk about non-linear functions. So again, just keeping things organized, highlighting my main ideas. And the first thing that I want to know about linear functions is that each input has exactly one output. Another thing about linear functions is that the rates of change are constant. And lastly, and more straightforward, the lines that we create are straight. So let's go ahead and graph some linear functions and see what they look like. And again, this is going to be a rough sketch. We're not going to focus on any specific points, but I want to go ahead and show you an example of what a linear function would look like. So again, we would have a straight line going this way. Draw my arrows at the end because it's ongoing. And then we would have lines going this way. So again, we can have a positive slope or a negative slope, like we've talked about in the past. Some examples of what linear functions look like in terms of equations are things like y equals 3x plus 4, y equals 1/2 x minus 5, and y equals 4x. Now let's go ahead and take a look at some examples of what nonlinear functions look like. So now we have nonlinear functions. And again, I'm going to go ahead and highlight that so we can separate it. Now with nonlinear functions, each input has exactly one output. So that doesn't change because again, it is still a function. So we're still going to have each input having exactly one output. Something that's different, the rates of change are not constant. And again, something that's also opposite, the lines are not straight. So they won't be a line. Now let's go ahead and see a rough sketch of what some different nonlinear functions would look like. So here's some graphs. Some examples of nonlinear functions might be something that looks like this. So even though we have two straight lines, they don't continue straight. We have like this point that they are changing at. Another nonlinear function would be something that looks like this. Again, it does not create a straight line. And lastly, another example of a nonlinear function might be something that looks like this. And these are actual functions. They're just nonlinear. So again, examples of nonlinear functions. Now, what do nonlinear functions look like in terms of equations? Let's go ahead and see some examples. Nonlinear functions are things like y equals x squared or y equals x cubed. Another example would be y is equal to the square root of x, or y is equal to the absolute value of x. Some more examples include y is equal to 1 over x, or y squared is equal to x. And last but not least, we might see some functions that look like this. Y is equal to x plus 2 times x plus 1. That is also an example of a nonlinear function. Okay, so now let's go ahead and see some example problems. So example problems. And again, because you guys know I love to highlight things, keep things organized. Okay, so let's say we have some directions, because we always have to see what the problem is asking us to do before we go on and solve. Let's say we see something that states, determine if the following is a linear function or not. Explain. So let's say for problem number 1, we have a function that looks like this. And again, just because we have a chart or a graph doesn't mean it's not a function, because functions come in different forms. So it's good to keep that in mind. All right, so we have x values and we have y values. And let's say for our x values, we have 0, 5, 10, 15. And let's say for our y values, we have 20, 16, 12, and 8. Now, if we want to figure out if this is a function, we have to find our rate of change. And in order to find our rate of change, we have to find the change in x and the change in y. So going from the first number to the second number in x, going from 0 to 5, I have to add 5. Going from 5 to 10, I have to add 5. And going from 10 to 15, I have to add 5. Now, what about my y values? Going from 20 to 16, I subtract 4. Going from 16 to 12, I'm subtracting 4. And going from 12 to 8, I'm subtracting 4. Now notice my changes in x are all the same, and my changes in y are all the same. What this means is this is a linear function. So determine if it's linear, yes or no. Yes, it's linear, and explain. The reason it's linear is because the rate of change is constant. So we can determine that it's linear. Now let's go ahead and look at a second example. Example 2. Let's say we have another chart with X and Y values. So again, we have X values, we have Y values. And let's say for our X values, we have 0, 2, 4, 6. And for our Y values, we have 0, 2, 8, and 18. Now we want to start by finding our change in X. I'm going from 0 to 2, I have to add 2. Going from 2 to 4, I have to add 2. Going from 4 to 6, I have to add 2. Now let's find my changes in Y. Going from 0 to 2, again, I add 2. Going from 2 to 8, I add 6. And going from 8 to 18, I add 10. Now my changes in X are constant because it stays the same at a rate of 2. However, my changes in Y are not the same. They are not constant. I go from 2 to 6 to 10, which is very different from one another. So this is an example of a non-linear function, since the rate of change is not constant. So no, it is not linear. Now let's go ahead and come back together so we can practice some more problems and get more familiar with the difference between linear and nonlinear functions.